We got 3.2, greatest common factor and least common multiple. Two different things, though they are, slightly related, which we're going to see. But we do need to remember that when we talk about factors, we are, again, just like we talked about last time with factors, it's multiplication, right? So that's why there is some relationship here between factors and multiples. So it's important that we got this note down here, right? It's very crucial to understand as we move into fractions, which is clearly coming because this is what we're doing, that finding at least common multiples is very, very important, okay? Now, you can use common factors as well, which is also very nice. But if you can find common multiples, again, for me anyways, when I start operating with fractions, that's what I do. I just find common multiples, and I don't really care if they're least common multiples either. When we start operating with fractions. Now, if you can find the least common multiple, it can make it more convenient, but it doesn't guarantee that it will. So if you're like, man, I just want to find any common multiple, feel free to do it. But if you want to stick to the least common multiple, you can. So common factors, okay, when they give us two values, and again, this would be in fractions in some way or another. But when we want to find common factors of two numbers, um, we're just looking at making a list of all the factors, which we did in the last lesson, by the way, right? We want a list of all the factors of a given value. Um, uh, and then we just, I guess, find any matches in the two lists. Those are common factors, okay? Now, it is possible for one of the two numbers to be an actual factor of another one, and that's okay. And I think we'll see an example like that. But whether we do or not, just understand that it may happen, okay? So do remember from when we went over multiplication, the two values that are being multiplied are factors, okay? So this would be a factor here, and this would be a factor here. And then the answer from the multiplication is a product. Factor times factor is product. Now, why is it the same name for both of those? Because the order doesn't matter. You can switch those factors together, and it's going to give you the same product, right? Commutative property of multiplication. But today, what they're going to do, they're going to give us numbers. Those are the products, and we've got to figure out what two numbers or other numbers multiply together to give us that specific product. All right, so here we go. List the common factors of the given numbers 63 and 28, which is part of our objective. Find the greatest common factor by listing. So listing means that we're just going to list the numbers. We're going to find all the common factors, by the way, because this one tells us to, but we'll also identify the greatest common factor even though it did not ask us to. So I'm going to start with 63 first, okay? And we'll list these in red. So again, I need something multiplied by something else to be 63. It doesn't have to be the same thing, although it could. I just need something multiplied by something else to be 63. Now, if you know some of your multiplication tables, you could come up with a couple values pretty quick. If you don't, then that's fine too. Because what we can do is use our divisibility rules. So I could say, oh, and I forgot one thing, right? First off, we're going to list 1 and itself. 1 and 63. And I'm putting some space between these because as I find other factors, I'm just going to list them between here, okay? So maybe that's too much space, maybe it's not enough. We're going to find out though. So I could say 1 and 63. That's a pretty quick one. The next up, I would say, is it divisible by 2? Well, I got a 3 in the ones place value. It's odd. So 63 is not divisible by 2, which in turn means that it's also not divisible by 4 or 6. Okay, now again, just like we did in the last lesson, I'm going over just the visual checks first. And if we know that it's divisible by 2, or it's not rather, like this example, again, it automatically eliminates 4 and 6. So I'll check. Other visual checks were 5 and 10, right? Well, if it were divisible by 5, you'd have to have a 0 or a 5 in the ones place value, but there's not. So it's not divisible by 5. So it's also not divisible by 10 either. Okay. Now that we're done with the visual checks, I go straight to 3. Okay. Well, our divisibility rule by 3 means we'd take those two values from the place values, 6 and 3, and add those together. If the number that I get is divisible by 3, which is 9, then the original number, 63, is also divisible by 9. So, well, 3. But since this one's divisible by 9, it's divisible by 9. So, I know it's divisible by 3, so I'm going to put that in the list. And we may not be familiar with our multiplication tables up to 63. So that means we're going to have to divide it and see what the other factor is, which is, in this case, the quotient. So 63 divided by 3. 3 goes into 6 2 times. 2 times 3 is 6. Subtract. That zeroes out, so we'll drop this 3. In the ones place value, 3 will go into that 3 once. So the other factor there is 21. 3 times 21 is 63. Okay. Well, we know it's not divisible by 4, 5, or 6. Is it divisible by 7? Well, there's no rule for 7s, but we do know that 63 is a multiple of 7. In fact, again, this goes back to the multiplication tables. 63 is the 9th multiple of 7. So my next number is 7. That is the 9th multiple of 7. Now, you could have said, well, I see when I divided by 3 here that it was 21. That was our quotient. 63 divided by 3 is 21. And I know 21 is divisible by 3, so I knew that it was divisible by 9. We talked about that a little bit last time. And the other way to know that a number is divisible by 9 specifically is if the two numbers add up to be something that's divisible by 9. And since we got 9 up here, we know that 63 is divisible by 9, which would be 7. Now, just like we talked about last time with factors, as we move from going from left to right, we're looking at going bigger. As we go from right to left, we're listing the smaller factors. But once they get close together, I mean, you just need to check any of the values between there. So this one, the only number between 7 and 9 is 8. And 63 is not a multiple of 8. So yeah, I gave myself a little bit too much space. I'll push these a little bit closer together right there like this, because I don't really need the space. And then we'll erase this other stuff so we don't get it confused, okay? So it looks like we got 6 multiples of 63. And before I move on, let me just double check and I'm just going to think, is there any other multiples maybe that I'm missing on this one? 3, no, maybe 3 and 9, 7. That 3 right there. Okay, yeah, this looks good. So that's, by the way, that is only the factors of 63. We still have to do 28. No problem. 28. So again, something times something else needs to be 28. Well, right away I can list 1 and 28 like this. Perhaps we'll have more, so I may need more space. We'll find out. Okay, now 28, I have an 8 in the ones place value, so I know that 28 is divisible by 2. So to find the other factor, I'm going to take the 28 and divide it by 2. 2 goes into 2 once. 1 times 2 is 2. Subtract. That zeroes out. So drop the 8. 2 goes into 8 4 times. So the other factor there is 14. And that's a pretty good start. Pretty good start. Okay. But since I got something that was divisible by 2 there, 28 divided by 2 is 14. 14 is divisible by 2. Well, since it's divisible by 2, I know it's also divisible by 4. And when I say it, I meant the 14. If you can take a number and divide it by 2, and its quotient is divisible by 2, the original number, 28 in this case, is also divisible by 4. Well, 4 goes into 28, yep, 7 times. 7 times 4 is 28. Subtract that out, you got 0 remaining. So 4 would multiply by 7 to get 28. Now we should think, well, is there any other values that I could include? See, again, now these numbers got closer together. We can check 3, though. We kind of skipped over 3 right there. So you could say, well, you'd have to add those two digits together. 2 plus 8 is 10, and 10 is not divisible by 3. So we know we cannot include 3 as one of the factors, which automatically excludes 6, by the way. Now, before I did 3, I probably should have did the visual checks. And I see in the ones place value is not a 5 or a 0, so it's not divisible by 5 or 10. So I didn't really need the second comma right there. I won't worry about pushing these closer together. But yeah, those are the factors of 28. Now it said, what are the common factors, right? That's what it wanted up here. So I need to go through this list and find any factors that are common. Well, the 1 and the 1, those are common. And that's okay to list the ones. That's all right. By the way, you can just kind of go through one of the lists, and if you don't find any matches, there's no real need to go through the second list. So I would say that let's do the red list, okay? And once we go through, we'll find all the matches. Anything that doesn't match, and so we wouldn't need to check the other list. So I'd say, oh look, we got the red 3, but I do not see any 3s in the purple list. Okay, so 3s are no good. No common factors with 3. In fact, you could even cross it out if you'd like. Okay, next up, 7. Well, 7, no, there's a 7 in common right there. So in the bottom left there, I got this 7, which is common. What about this 9? Is there any 9s in common? Nope, no 9s in common. What about 21? Nope, not any 21s in common. 63? Nope, 28 only goes up to 28 as a factor. So 63 is not a factor. Which means, of course, that 2, 4, 14, and 28 have no common factors with the red list. So the only common factors we get from 63 and 28 are 1 and 7. But like I said in the beginning, just like we have the name of this, part of the name of this lesson, the greatest common factor, we just found common factors, which is CF. Greatest common factor, GCF, is just the bigger of these numbers. And that number is 7. So if by chance this one had asked, what is the greatest common factor of 63 and 28? The answer to that would be 7. But keep in mind, I believe there are questions. Well, no, I don't remember seeing questions like this on this particular assignment. But if you do, you would want to list both of these. So there is a lot of division on these problems. That should be okay. We should be at least feel fairly comfortable with division at this point. And yeah, there could be lots of it. So here we go. Objective. Yeah, again, we're finding just common factors of these numbers, 60 and 132. Well, those are good numbers to start with. Let's get started. So I'm going to start with 60. Let's see if we can do that. And I'll do 60 in red. 60. So 60 needs to be the result of two factors, the product of two factors. And yeah, 60, of course, would be 1 and 60. That would work. And again, maybe I've given myself too much space between, perhaps not enough. We'll find out. But I'm going to start with just that much. And again, I'm going to do my visual check with my divisibility rules. And right away, I see that there's a 0 in the ones place value, which means that 60 is divisible by 2. Now, I'm actually just showing the work kind of in random spots. Some of you may prefer that I do it underneath. I don't know. We're going to need all the space we can get on this, trust me. So 60 divided by 2, 2 goes into 6 3 times. 3 times 2 is 6. So we can subtract that out zeros, and then we need something to hold that ones place value. 2 goes into 0 exactly 0 times. So this factor of pair would be 2 and 30 right there. 2 times 30 is 60. Okay, so that works. Now again, just like we saw in that last example, we got 30 here after dividing by 2. And 30 is also divisible by 2, which means that we can take 60 and divide it by 4. And we should get just a natural number out of this. So 4 goes into 6 once. 1 times 4 is 4. Let's subtract 6 minus 4 is 2. Drop the zeros, that's 20. 4 goes into 20 5 times. So 4 would be paired with 15. on this one. And some of you noticed I gave myself some space. That's because there's other values, which we'll get into. All right. So again, that's just starting with the visual check to see if it was divisible by 2, but then it led to divisibility by 4 as well, and that's okay. The next visual check would be, is it divisible by 5? And yeah, we got a 0 in the ones place value, which means 60 is also divisible by 5. 5 will go into 6 once. 1 times 5 is 5. 6 minus 5 is 1. Drop the 0 and make that 10. 5 will go into 10 2 times. 2 times 5 is 10. So you got 0 remaining out of that one. Just cancels that stuff out, just like it did over here. So 5 would be paired with 12, like this. All right, but we also see that since it ends in 0, it's also divisible by 10. So I'd say, oh, we got 60 divided by 10. Now we got those zeros in the ones place values, and just like we've talked about with division by tens, or base tens, is we can cancel out those zeros, which then just makes this problem a little bit easier. Do remember, though, that we were talking about 10. I'll put it in red. 10 right here. So 1 will go into 6 times. That's pretty easy. So that would pair 10 with 6. Actually, I should have given myself some space there. Put on the wrong part. 10 and 6. Okay, so I kind of ran out of space right there. Kind of. But there's another value, right? We did the visual checks, 2, 5, and 10. We should always check 3 if we can. And so, well, is 60 divisible by 3? Let's find out. 6 and 0, 60. 6 and the 10, 0 and the 1. 6 plus 0 is 6. Well, 6 is divisible by 3, which means that we can take 60 and divide it by 3. So 3 will go into 6 twice. 2 times 3 is 6. Subtract 6 minus 6 is 0, so drop this 0. 3 will go into 0, 0 times. So those two factors are 3, and see why I gave myself some space there. 3 and 20. Now, we should see if it's divisible by 9, and remember there's two ways to see if a number is divisible by 9. If you divide it by 3 and that quotient is divisible by 3, then it's divisible by 9. But 2 plus 0 is 2, which is not divisible by 3, which means 60 is not divisible by 9. The other way to check if we have divisibility by 9 is if we add the two digits and that sum is divisible by 9. 6 is too low to be divisible by 9. So it's not divisible by 9. Well, we can probably check some of those off values like 7. Well, 60 is not a multiple of 7. It's also not a multiple of 11. Is it a multiple of 13? Nope, it is not. So that kind of checks off some of these other values that are between here. And yes, we kind of ran into the numbers that are closest together, 6 and 10. We checked all the values between that, which show that they are not multiples, or 60 is not a multiple of them, or that 60 is not divisible by those. So those are our factors of 60. That's a pretty good list right there. 6, 7, 8, 9, 10, 11, 12 numbers. That's pretty good. But we're not done. Yep, still got to do 132. So let's get started on that one. 132. I'll do this one in purple. And yeah, we need to just start with the list. 1 and 132. And again, this one, hopefully I got enough space. We'll find out. In fact, I'm going to need some space for the division, which I'll do below. Well, 132, it ends with a 2 in the ones place value. So I do know that 132 is divisible by 2. Let's check, see what that is. 132 divided by 2 won't go into 1, but it will go into 13 6 times. 6 times 2 is 12, so subtract, get a 1, drop the 2. Yep, 2 goes into 12 6 times again. So that gives us the pair 2 and 66 right there. But we see again that the quotient 66 was also divisible by 2, which means that 132 is again divisible by 4. 4 won't go into 1, but it will go into 13 3 times. 3 times 4 is 12. See that? It's kind of a recurring theme right there. 12 is a pretty common number. Say 4 multiples. So 3 times 4 is 12. 13 minus 12 is 1. Drop the 2. Boom. 12 again. Makes that 33. So that'll cancel out the 12. So we also have the number of 4 and 33. I feel like I should have wrote those smaller, but we'll see. Okay, so that takes care of 2 and 4. Let's see about 5. Well, it's not divisible by 5 because we got a 2 in the ones place value. So it's not divisible by 5. It's not divisible by 10. That's our other visual check because it's not a 0 in the ones place value either. So let's see if it's divisible by 3 though. Okay, so 132. Let's add each of the place values together. 1 plus 3 plus 2 is 6. So it is divisible by 3, so I'm going to need to include that in the list. Let's see what it is though. 132 divided by 3. 3 won't go into 1, but it will go into 13 4 times. 4 times 3 is 12. Subtract, and again we see that 12 again. 3 will go into 12 4 times. So that should have been right here if I list it in ascending order, not that you have to. So we've got the first 4 factor pairs together. We know it's not divisible by 5, but we do know it's divisible by 6. How do we know? Because I have 2 and 3 in the list, and we see that 2 and 3 are on the list for the red for the 60. And yep, sure enough, 6 showed itself right there. So I know that 132 is divisible by 6 because it's divisible by 2 and 3. So I'm going to put 6 in the list. Let's see what we get. 6 won't go into 1, but it will go into 13 2 times. 2 times 6 is 12. Subtract, we get a 1, drop the 2 to make that 12 again. See, that occurs again with 12. So that is 6 paired with 22. All right. Now, is it divisible by 7? No, it is not. Is it divisible by 8? If it were divisible by 8, then when we divide it by 4, its quotient would need to be divisible by 2. It is not. It's 33. So it's not divisible by 8. Is it divisible by 9? Nope, because when I added the numbers together, it got 6. And 6 is not divisible by 9. Or, like we talked about before, the quotient when we divided it by 3 was 44, and that's not divisible by 9. 4 plus 4 is 8. So again, that's just 2 different ways to tell if a number is divisible by 9. We know it's not divisible by 10. It's not divisible by 11 either. Let's see. 121. No, it is divisible by 11. I apologize. Now, how could you know that it's divisible by 11? Because see how we've got these other factors? These are divisible by 11, which means that it should also be divisible by 11. I kind of ran out of space there, but let's see if I can fit it right here. Okay? So I'd say 11 and 132. 11 won't go into 1, but it will go into 13 once. 1 times 11 is 11. Yeah, that's a 13, by the way. Sorry about my handwriting. There's a 2. Drop this other 2. 11 will go into 22 2 times. So that would be the next factor, 11 and 12. There we go. Now, it feels like I missed something on this one. It is not divisible by 18, and that's okay. But I just, again, and this is where it may take some time. Just kind of think, well, is there any maybe some values that we missed? And you can kind of go through this. We know it's not divisible by 5, 7, 8, 9, or 10, 13. And really, once you get to the 2 numbers closest together, you can stop. But you could continue 13 to 21. That's not divisible by any of those, so we can stop there. So we do have our list, and we just barely made it with space on that on the 132. We got the factors of 60. Let's go and list our common multiples. I'll do that in the bottom left. And yeah, we should always have a 1 in common, no matter what 2 factors are, or the 2 products are. So 1 is good. I got a 2 that's common for both, so let's put the 2 in there. I got a 3 that's common for both as well. There's the 3, 4 also. That's good to see. Yeah, we got a 6 that's common there. The 5 wasn't common. Nope. No 5's common. No 10's in common. I see 12's in common, though. No 15's in common. No 20's. No 30's. No 60's. And no 11's, 22's, 33's, 44's, 66, or 132's. Not that I had to do those purple numbers, but that's a pretty good list right there. And we've ended with 6 common factors between these two numbers. Now, it's okay to have a big list like this. That's all right. It's not a problem. Uh, but you'll want to remember this part. It's going to be part of the next part of this lesson. But if it asked for the greatest common factor in this list in green that I got there at the bottom, of course, 12 is the greatest common factor. So if it asks for it, just know, and it's coming, that greatest common factor is 12. Now, something you need to be aware of is that they had to be common factors, right? So when we found them in these lists, it's not like they get listed twice, okay? Because that's a common mistake in these types of problems. Is students say, well, at 2 and 2, so I list 2 twice. No, we do not list it twice. We just list it once because it's only common once. Okay, now if it were common twice, that would be a whole different story, but there's no need to show it twice in a list like this. All right, so that leads us to greatest common factors, right? And listing them out is nice, and it was fun to do that. I think we all enjoyed that, probably more than we should have. However, we're going to be using a different method, and this method we saw in the last lesson, and that's prime factorization. Well, what did we do to make prime factorization? Well, we made a factor tree. So what we're going to do is we're going to find all the prime factors, and all the common prime factors that we find, we're going to multiply those together. Okay? That's all you got to do to find the greatest common factor. First, find your common factors and the common prime factors, and then multiply those together. That tells you what the greatest common factor is. Which, by the way, it would have worked in the last examples that we just did. But we're gonna be looking at different examples. All right, find the greatest common factor of 25 and 15. Okay, and these aren't even big numbers. It's not too bad. So we should understand some of these factors. And again, with prime factorization, when we've used a factor tree, there's no need to use 1 because 1 is not prime, first of all. But it also means that if you did use 1, you could continue that branch infinitely because, well, 1's not prime and it's the identity property, so it would just continue on forever. So we're not using 1 in the factor trees. So, and you may use divisibility rules if you choose, but I see 25 is kind of a small number. I have a 5 in the ones place value, which means I know it's divisible by 5. So that takes us back into the multiplication tables. I know if I take 5 and multiply it by 5. So we got 5 and 5, which both of these, by the way, are prime. So we got 5 and 5. Now, that's nice and it's pretty. You know, it's branched out. It doesn't look like a tree, but it's a factor tree. So what I do, just to show, I don't know, this is kind of a different way to organize the work, but I'm going to put these down below, okay? 25 is the number I'm looking at. Its prime factors were 5 and 5, okay? So I list those out in a list horizontally like I've shown in this example, horizontally, okay? Now I'm going to do that with 15 as well, and I'm doing this on purpose because it's going to help me to identify common factors once we get this list for 15 together. So I'm going to split 15 up. Again, I'm not using 1 in 15. So I want prime factorization. It has a 5 in the ones place value, so I know it's divisible by 5. 5 times what is 15? We should know that's 3. So 15, its prime factorization is 5 and 3. Just a little bit more space. Now what I need first is common factors, okay? If I can find common factors here, then I'm going to multiply those together, and that will be the product of the multiplication will be my greatest common factor. However, on this one, I see only 5s that match. Now you could say, well, which 5s match? You only have one set that matches. That's the real important part. For example, I'm going to do these 5s just because they're above and below each other, which makes this convenient. If you wanted to circle these 5s, that's fine. I don't know. I wouldn't even say that looks sloppy. It's just, different, I guess. Plus, this seems like it's more convenient. So what is a factor that's common? 5 is a factor that's common. Are there any other factors that are common? No. I mean, there is this 5 right here, but we've already used up this purple 5, and the 5 and 3 don't match. So there's actually no need for this one to have multiplication, which means that 5 is also just the greatest common factor in this problem. Now that will eventually seem unusual to have only one common factor, but it's okay if it does, and I actually kind of like it because it makes this type of problem go not only smoothly but quickly. Is when we look at these types of problems, it is possible to have the same common factor listed in the common factors. This one just only had one factor that was in common between the two. So in the future, just understand, it is possible to have repeats in this list below, but this one just had one because we can only pair this once together. So I use the factor tree not only because, well, I guess it's pretty, but it's convenient, right? Like, and well, you could say, well, 25 and 50, and it's not too bad to list all the factors, which is true. But once we start getting into some of the bigger values, you'll see the merit of using this this factor tree business rather than saying, okay, well, and having to continually do repeated division like we did on those last problems. You know, like we did, what was it, 132 divided by 6, and then by 3 and 4, and all those values. But the factor tree allows us to break this up into smaller, more manageable problems, I think, anyways, which is why I use it when we find greatest common factors. Going back to your question, though, of when do we know when to use it, it doesn't actually matter which one you use. You could have used just the list like we did on those first two examples for these two. Um, but it is also possible to use the factor tree like this. And again, I'm going to continue using the factor tree just because, um, well, really out of convenience, but we want to get used to these factor trees because it's a valid method for doing other things as well. All right, greatest common factor of 9 and 81. Oh, all right. Well, 9 splits up. Again, we can't use 1 and 9, but we can use 3 and 3. 9's a pretty low number. So again, I'm going to list these below. 9 is the same as 3 times 3. Very nice. Well, 81. What about 81? Well, there's a couple different factor pairs you could use at this point. You could go through the divisibility rules if you'd like, which is kind of leading us into lists, but I want to use the factor tree. So you'd say, well, it's not divisible by 2 because there's a 1 in the ones place value, so it's also not divisible by 5 and 10. That would be easy. But I do know it's divisible by 3 because 8 plus 1 is 9. In fact, if you looked at 8 plus 1, 80, the 8 in the tens place value and the 1 in the ones, it's 9. So if you wanted to, you could actually divide it by 9 as well. Now, let's say that you didn't notice that because we do want you to be more familiar with divisibility by 3. So I'm just gonna stick with the 3 on this, okay? Now, you probably don't know your 3 multiplication tables up to 81, and that's okay. I don't either. So I would say 3 goes into 8. 2 times 2 times 3 is 6. So subtract that out and get 2. Drop the 1 to make that 21. 3 will go into 21 7 times, and yep, that zeroes out all that stuff right there. Okay, remainder of 0. So 27 is the other factor. Well, is 27 prime? No, it is not. How do you know? Because it's well, it's not a even number in the ones place value. It doesn't have to be. I do know that 2 from the 20 and the 7 from the ones is 9. And 9 is divisible by 3, which means 27 is also divisible by 3. We want you to know that, by the way, would just be 9. So I'm going to put a 9 right there. Okay, and we know 9 would split up into 3 and 3. Okay, so this kind of goes back to that question of, well, what if they repeat? It is possible to have repeating values as the common factors. So 81, I'm going to split this up between, what do we got? Just 3's, right? 1, 2, 3, 4 3's right there. And we need first I'm going to start with common factors. I just want to find common factors. So I'm going to circle these 3's. Again, you could have circled it with any other 3's, but then be careful because some students I really like to cross these things over, and then it does look a little sloppy. Not that that matters. What matters is that you can keep track of which values you've circled. So I like to do it above and below if I can, just like I did there in green. So is there a common factor? Sure. Those threes that I circled in green result in that 3 that I have in green there at the bottom. Are there any other common factors? Yeah, there's this other set of 3s right here, which I circled in orange, so I'm going to keep it in orange, right? Now these are just common factors, but it doesn't tell me directly what the greatest common factor is. In order to find the greatest common factor, I just need to multiply those two values together. And 3 times 3 is 9. So our greatest common factor is 9. Something else that you'll want to be aware of is that these two 3s in purple that I have here on the right, they were not used because there were no other 3s from the red list to pair them with, right? We had already paired the two 3s in red with these other two purple 3s. So these ones kind of get left out. We will do something with those eventually in a technique that we're going to be looking at for multiples, even though you may not use that method, but I'll show you how it works later on. All right, yeah, find the greatest common factor of 6 and 48. We can do that for sure. So, again, we look at 6 first, and I'm just going to branch that out with the factor tree. That's just 2 and 3. That's not too bad right there. So I got factors of 6. Boom, 2 times 3. Well, what about 48? Now, again, you could say, well, I know 48 is divisible by 2 because of the 8 in the ones place value. I'm actually going to skip over that right now because, again, we should be at least slightly familiar with our multiplication tables. And 48 splits up into 4 and 12. Now, is that the only other factor pair? No, of course not. And 4 and 12, neither of those are actually prime. So I'm going to have to split those up as well. The other pairs you could have used, I believe, 6 and 8. That's a common one. But I got 4 and 12, so that's what we're going to do. 4 would split up into 2 and 2. All right, those are both prime. That's good. 12 splits up into, let's see, what should I use? 3 and 4, I guess. And 4 again splits up into 2 and 2. So again, just to reiterate this, you don't have to be using these specific pairs. For example, 12 could have been split up into 6 and 2, but you'll still end up with these 3 prime factors of 12. So even though your list may even come out in a different order than the one that mine is in, that's okay. So what are our factors of 48? I'm just going to list this from left to right. 2, 2, 3, 2, and 2. Lots of 2's right there. Now that we have all of the prime factors of 6 and 48, what I would really like are the common factors of 6 and 48. Well, we just need pairs that match, right? Like, for example, this set of 2's, one in blue, one in red, that's a match. So I have a 2, that's a common factor. And also these 3's right here that are common factors. So I list that in the common factors rather. Now those are just the common factors. I still do need the greatest common factor, which is just the multiplication of the common factors. Right? Factor means multiply, which is why we are multiplying. 2 times 3 is 6. Now, just like we saw in that last problem, though, 6 was one of the original values that it gave us. That's okay. Right? Like in that last example, 9 was one of the original values, and that's all right. So it is possible that one of these two values, though it doesn't happen very often, could be it could be the greatest common factor. Now, if you knew this, right? You're saying, well, we know 48, we know this multiplication right here, or 48 is a multiple of 6. If you see something like that, then this is another way to tell pretty quick if a value is the greatest common factor. And that would have worked with 9 and 81. 81 is a multiple of 9, so just like we did on that last example. So you would know that 9 is the greatest common factor. So yeah, let's show that. Let's show that 48 even though I may split it up differently, and in fact we can do it 2 different times. But if I split this up differently, I'm still going to get the same prime factors. So I'd say, yeah, let's use that example, 6 and 8. So 6 splits up into 2 and 3, both of which are prime. 8 splits up into, we'll say, 4 and 2. 2 is prime, and then 4 splits up into 2 and 2. Now, the order is different, though, right? We still got 4 2s and a 3. 1, 2, 3, 4 2s and a 3. All right, greatest common factor of 136 and 104. Now, since these numbers are big and they're not, I mean, when they were smaller, it was like, okay, we know the multiplication tables, or we should, and so we can do those kind of quickly. So, but with bigger numbers like this, we're going to use long division. And even though um, we use long division in making lists of factors, I still think it's faster to do it with a factor tree, because it's going to give us smaller and smaller numbers until we get to just the prime factors. So here's what I mean. Okay, I'd say 136. Again, if you got your multiplication tables down, you could find other stuff. But the first thing I would notice here, because I don't know my multiplication tables up to 136, I'd say, oh, look, it's got a even number in the ones place value, so I know it is divisible by 2. Now, I don't know what to multiply 2 by to get 136. So that means I'm going to have to use some long division up here and see what that other factor is. 2 won't go into 1, but it will go into 13 6 times. 6 times 2 is 12. Subtract, you got 1 left over. Drop the 6 to make it 16. 2 will go into 16 8 times. So that'll cancel out the 16, and the other factor there is 68. Now 68 is not prime. How do I know? Because we got an 8 in the ones place value. So it also is divisible by 2. So we'll have to do that long division as well. 68 divided by 2. 2 will go into 6 3 times. 3 times 2 is 6. That cancels out the 6's. Let's drop the 8. 2 goes in 8 4 times. So the other factor is 34. But 34 also is not prime. It can be factored out by 2. It's divisible by 2 because of the 4 in the ones place value. So let's divide it by 2. And if you got your multiplication tables up to 34, that's good. But let's say that we didn't. 2 will go into 3 once. 1 times 2 is 2, so subtract. Got 1 left over. Drop the 4. 2 goes into 14 7 times, so the other factor there is 17. Now, 17 is a weird number. It's odd, first of all, so I know it's not divisible by 2 or 4, for that matter. It doesn't end in 0 or 5, so it's not divisible by 5 or 10, which is good to know. Is it divisible by 8? No, because it has to be divisible by 4, but it's not, because it's not divisible by 2. There's a little chain reaction right there. Is it divisible by 3? Well, 1 plus 7 is 8, which is not divisible by 3, so that doesn't work. It's not divisible by 5. It's not divisible by 7. It's not a multiple of 7. Or 9 by that. Well, because it's not divisible by 3. So, 17, as it turns out, is prime. Now, we don't necessarily need to memorize that. You can go through your divisibility rules to make that determination. But yeah, it is prime. Okay, now if you memorize that, that would have gone a lot faster. But again, it's not necessarily required that you do. So 136, its factors are 2, 2, 2, and 17. Well, what about 104? Let's see what happens with 104. 104, it has a 4 in the ones place value, so it is also divisible by 2. Let's see what we get. 104 divided by 2. 2 won't go into 1, but it will go into 10 5 times. 5 times 2 is 10. It canceled out the 10. Drop the 4. 2 goes into 4 2 times. So 2 times 52 is 104. Well, 52 is not prime because it's an even number in the ones place value, so it also is divisible by 2. So 52 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. Take that away from the 5, and you got 1 left over. Drop the 2 to make it 12. 2 goes into 12 6 times. So then we got 26. I should have given myself more space. But 26 is, again, we got an even number in the ones place value, so I know it is also divisible by 2. And I just put the 2 there to make sure I got enough space. 26 divided by 2. 2 will go into 2 once. 1 times 2 is 2. Subtract the 0 that out. Drop the 6. 2 goes into 6 3 times. So that's 13, which is prime. It can't be divided by 2, 5, 10, Since it's not divisible by 2, it's not divisible by 4 or 6 or 8. And it's not divisible by 3 because 1 plus 3 is 4. So it's just prime. And that ends all the branches in the factor tree, just like it did in red. So what are the factors of 104? 2, 2, 13, and 2. And yeah, I did actually list those not above and below each other, just to show that it doesn't really matter where they are in the list. If they match above and below, then it's a common factor. So let's find, first off, let's find our common factors first, okay? So I'd say, look here, we got a 2 in common, just above and below. That was the first match I saw. And so that's a 2 that's common. I also have this set of 2's that are common. So there's another 2 that's a common factor. And then, yep, we got 2's, even though they're not right directly above and below each other. That's okay, they don't have to be, but there's another 2 that's in common. Now, we do have the 13 and 17, but they are not common factors, so we can't include those in our list. So now that we have our common factors, we can go into our greatest common factor, which is 2 times 2 is 4, times 2 is 8. So our greatest common factor is 8. All right, find the greatest common factor. Now we got 3 numbers, okay? Now it's important to remember that when we want common factors, when you see 3 numbers like this, and it says we want greatest common factor, and you're looking for common factors, it has to be common for all of the values. Not just 2 of them, not just 1, all 3. So if, for example, it gave us 4 or 5 numbers, then we would need common factors in all 4 or 5 numbers. But this one's only 3, so that's good. So 18, right? Let's start with 18. I'll do that one in red. Again, we'll use a factor tree to figure out its prime factorization. 18, well, you could use 2 and 9 if you want. You could use 6 and 3 if you saw that one first, and that would be okay. So I got 2 and 9 though. So 2 and 9, 9 is divisible by 3 there, 3 and 3. So our prime factorization from 18 is 2 times 3 times 3. Boom, 3 factors right there. Not too bad. Well, what about 36? I'll do 36 in purple. So 36, and again, you could say, well, it's divisible by 2 because of the 6 in the ones place value. I'm going to use something a little bit more familiar on this one. I'll say 4 and 9. Okay? So I'd say, oh, well, 4 can be split up into 2 and 2. And 9 can be split up into 3 and 3. Right? So all those are prime, by the way, which means that 36 splits up into all 4 of those. 2 times 2 times 3 times 3. So that is 36. What about 24? A few different options on this one. 2 and 12, 3 and 8, 4 and 6. So much to choose from. I'm going to choose 3 and 8. But again, you could have chosen 2 and 12 or 4 and 6. 3 is prime, so I circle it. 8 splits up into 4 and 2, so there's a 2 that's prime. 4 splits up into 2 and 2, which are both prime. So 24 here at the bottom. Its prime factors are 3, 2, 2, and 2. Oh, not too bad. I possibly could have listed those better when we start putting these matches together. And yeah, that's what we want now is the common factors, is just looking for matches, in this case, triplets, right? Matches and triplets. So it's a, look at these 2's right here. Those 2's match. I got a 2 in red, purple, and blue. So that means they are all common factors of those values. Now, I kind of did this one purposely out of order, just so that if you list these this way, it is possible that you may need to cross these, at least if you're going to circle them like this, okay? Such as these 2 3's and then this 3 right here, right? That shows the 3 that's common in red, purple, and blue, which means that 3 is also another common factor. Yeah, these are being multiplied. So we should look at the other values, okay? Like this red 3 right there. It has a purple 3 in common, but no other blue 3's in common. Same with purple 2 right there. He's got a blue 2 in common, but no other two red 2s in common. So none of these other values, although they have pairs, again, it needs to be common for all three of those products. So while they exist, they're just not, they don't have any common factors to be put into the list. Which then leads us to the greatest common factor is just the multiplication of all of the common factors. 2 times 3 is 6. So 6 is our greatest common factor on this problem. All right, find the greatest common factor of 25 and 6. All right, again, they're not two big numbers, but 25, we've done that before, 5 and 5, right? 5 times 5 is 25, so let's go and list these out here. 25 is 5 times 5, and then 6 splits up into 2 and 3 as its prime factors. So 6 has factors of 2 and 3. Well, what do we need? We need first the common factors, and we'll multiply those together. The problem is there are no common factors. Well, that creates a little bit of a dilemma, okay? Remember that if you can't find any common factors with prime factors, then you'll probably need those phantom ones. Remember, a phantom 1 is the identity property, so you could show anything times 1. And now we can actually see the common factors, in this case 1. Which means if you ever see values that don't have common factors, they'll always have a common factor of 1 because 1 is the identity property. So you can multiply anything by 1 and get itself back. Boom. Common factor of 1. Yeah, it is not just the common factor. Yes, that's correct. It's the greatest common factor. Just as a side note to all this factoring business, just understand that factoring is going to come back in a small way, I would say, in 980, if you have to take 980. It's going to come back a big way in 1010, okay, in a big way. So right now we're just kind of scratching the surface. They're going to get into all kinds of factoring in 1010 especially. So just know that, I mean, we can debate about how important it is, but in terms of mathematics and how much you'll be using it a lot in later classes. Well, that leads us then to multiples. So the product of a number and a natural number, just that's what a multiple is. Now, we've seen multiples though before, okay? This should not be new vocabulary for us. I think we did a lot of it in the last lesson, but uh, well, we did it usually by listing the values out, meaning that we were adding those numbers together. So remember, and we're going to show you two different ways to find multiples, at least common multiples. Uh, but I'll let you know right now that the method that I prefer when finding multiples, or even common multiples, is the listing method. Now, of course, this goes a little bit faster, at least with smaller numbers, if you know at least the first 12 multiplication facts in the multiplication table, right? Just like we've shown before. But even if you didn't, I would still think that the listing method would be a little bit faster, or at least more convenient, okay? So yeah, I'm going to be using the listing method on this one. Now, of course, multiples of 9, this is nice. If I used strictly the listing method, of course, the first multiple of any number is itself, right? Because that's the identity property. Now, I'm going to show all of the multiples in purple, but I'm going to show how we would list these with the work in green. So I'd say, well, 9, you'd have to add 9 to get the second multiple there. So when I add these two together, that will be the second multiple, 18. Okay? But like we've seen before in the last lesson, if I just continue to add by 9, it's going to give me the other multiple. So 8 plus 9 is 17. Carry the 1. 1 plus 1 is 2. So 27 is the third multiple. Add another 9. And 7 plus 9 is 16. Carry the 1. 1 plus 2 is 3. 36. Add another 9 together with a 36. That'll be our fifth multiple. 36. 6 plus 9 rather is 5. 15. Carry the 1. 1 plus 3 is 4. 45. That's the fifth multiple. This one asked for the first 9 multiples. That's all right. Just need a little bit more space, that's all. 5 plus 9 is 14. Carry the 1. 4 plus 1 is 5, 54. That's our sixth multiple. Add another 9 there. I'm trying to write a little bit smaller. So 4 plus 9 is 13. Get a little bigger. Carry the 1. 1 plus 5 is 6, 63. Then plus another 9 right here. So 63, that's the seventh multiple. 3 plus 9 is 12. Carry the 1. 1 plus 6 is 7. Eighth multiple, we just need one more. Let's add another 9 there. And 2 plus 9 is 11. Carry the 1. 1 plus 8. 1 plus 7 is 8. There we go. There's our first 9 multiples of 9. I'll box these in just so it kind of sticks out a little bit more. Now, 9's a nice number because if you remember from a little while ago, if you just use your fingers, you can use the finger thing to count by 9s, right? You put your thumb down as a 9. You put the next finger down, you see the 1, and then the 8, that's 18. And then put the next finger down. Now you got 2 up and 7 up. That's 2, 7, 27, and so forth. So now that's only unique to 9. So if it asks for the first 9 multiples of something else, then yeah, this method works. Or if you have the multiplication tables of 9 just memorized, then yeah, you wouldn't need to do that addition. So why did I show this addition by 9, especially where we expect you to memorize at least the first 12 multiplication facts for 9? Well, the reason I did that is because we're going to see values that are maybe a little bit less familiar than 9, such as, well, starting at 13 and going all the way up as far as they need us to go. Like this one. Well, it's the first, and this one only wants the first 4 multiples, that's okay, of 14. Now remember, you'll always start with the first value, just, well, 14. And again, I'll do my work in green here. So 14 is my first multiple. All my multiples will be in purple. My work in green. So my second multiple would be after adding 14. 4 plus 4 is 8. 1 plus 1 is 2. So 28 is the second multiple. We're halfway there, by the way. Add another 14. That'll be the third multiple. 8 plus 4 is 12. Carry the 1. 1 plus 2 is 3. Plus 1 is 4. 42 is the third multiple. We only need one more. But again, just having the skill to be able to find extras if you needed to is pretty crucial. So 2 plus 4 in the 1s, that's a 6. 4 plus 1 in the 10s is 5. 56 is the fourth multiple. So there we go. The first 4 multiples of 14. Now the other method is to just do straight multiplication, right? Like you could have said 14 times 1 and got 14. You could have done 14 times 2 and got 28. And then 14 times 3 to get 42. And 14 times 4. I just like the progress of being able to add these together because eventually, the numbers you're going to get from here, you may have to add the numbers together anyways. So this is kind of my preferred method for finding multiples. I mean, outside of using a calculator, of course, but of any values that are beyond 12. All right, so that is finding multiples, okay? Finding just multiples. But now we want common multiples, okay? And I'm just going to, if I haven't emphasized this already, is lowest common multiples are crucial, not lowest, but common multiples are crucial in operating with fractions, particularly with addition and subtraction. And I know we haven't seen fractions yet. Well, I mean, we've seen them, but we haven't really operated with them, which is okay. All right? The smallest number that is divisible by all the given numbers. Okay, that's a technical way to do it. I prefer to look at this in terms of listing, like we just did with 14 and 9, okay? So you just got to find the lowest multiple that is common for the however many numbers they give us. Usually it's just 2, okay? So we're going to get 2 numbers, and I'm just going to list all the multiples of those numbers. And then until I find one that's at least common, And if I can find a lower one that's common, then that would be the lowest common multiple. But again, keep this in mind when operating, even when we do get to fractions, common multiples are all you really need. Okay, so as long as you could find any common multiple, you'd be in good shape. And they say, well, the lowest common multiple is convenient when you start looking at fractions. That's true some of the times, but it's not always true. Okay, and we'll explain more on that later when we get into explicitly into fractions. All right. So find the least common multiple of 15 and 3. Oh, okay, we can do that. So I'm going to start with 15. I'll do this. I'll show the multiples of 15 in red. And I'm starting with 15, by the way. I hope that's okay. You could start with 3, and some of you know the answer to this right away without having to do any of this work, which I'll get into here in a second. So I'll do the work in green here. So plus 15 right there to the red. 5 plus 5 is 10. Carry the 1. 1 plus 1 plus 1 is 3. So that's my second multiple. Let's add another 15 to find the third multiple. So 0 plus 5 is, well, 5. 3 plus 1 is 4. Okay. I'll do one more. And by the way, I'm doing this knowing that I don't really need to, but that you can. 5 plus 5 is 10. Carry the 1. 1 plus 4 plus 1 is 6. Now, another reason I'm doing this is because you may not have known that all of this was actually unnecessary. But until you know that, doing this and just at least finding the first 4 or 5 multiples of a number is at least good practice, okay? But again, some of you know the answer to this, and that all the work that I just barely did was actually quite obsolete. So we can do the same thing with 3, and I'm not going to do the addition with the 3's because we should know the first several multiples of 3, right? And I'm just going to start listing these, even though you'll see the common multiple appear before I finish. Okay, so 3 is the first multiple, then 6, then 9, then 12, then 15, then 18, then 21, then 24, 27, and 30. I'll stop there. That's 10 multiples. That's pretty good. In fact, I don't usually go up to 10 multiples, but I did this on purpose because we'd say, all right, I've got this list, right? I got this list in purple of the multiples of 3. Is there any common multiples? And you could say, well, look, you got a 30 here and a 30 there, right? Well, those are common multiples, and that's good to know. But are they the lowest common multiple? And that's where the answer is no. They are not the lowest common multiples because we did have this 15 right here and this 15 right here, okay? So just between these two, the lowest common multiple would have been 15. So again, some of you would say, well, you did all that work and you wasted our time. No, I hope not, because this won't always work this way, of course. And so just finding the first few, in fact, sometimes it'd be like the third one, and we did 4. Okay, again, I recommend listing these out and seeing what they are, because it gives you something to fall back on. And just by chance, if I listed up to 60 and we got up to something else here, but there was no common multiples, then we got to expand. We would have to expand both of the lists, but we didn't have to in this case. All right, find the lowest common multiple of 32 and 48. And again, I'm just going to be using the listing method. So I'll put 32 in red again. I'll show my work in green. So that 32, of course, is the first multiple of 32. So just add another 32 there. 2 plus 2 is 4. 3 plus 3 is 6. All right, let's add another 32. And I am kind of doing this blindly, right? I don't know what the multiple of 48 is that matches, but I can continue until I find something that does, or until I feel like I can stop. Okay, so 4 plus 2, that's 6 right there in the ones. 6 plus 3 is 9. And let's add it. Let's do a few more, and then we'll stop. Okay, and then we'll check on 48 and see if we can find any common multiples. So plus another 32. 6 plus 2 in the ones. That's 8. 9 plus 3 in the tens. That's 12 right there. So what do we got? 4 multiples so far. Let's do a couple more at least. So add another 32. 8 plus 2 is 10. Carry the 1. 1 plus 2 plus 3 is 6. Drop the 1. There we go. All right, let's do one more. So adding another 32 here. 0 plus 2 is 2. 6 plus 3 in the tens, that's 9. And then drop the 1. 192. That's a good place. And again, if I need to expand that, we will. So let's go to 48 then. 48. So there's our first multiple, and yeah, we don't see a match yet, so clearly we would need to continue. Let's add another 48 right there to find the second multiple. So 8 plus 8 is 16. Carry the 1. 1 plus 4 is 9. 96. Oh, yep, we've seen that before, right? 96 and 96. So since these two match, they're common, of course, and we could check anything less than that, right? Like 64 and 32, but there's no matches in purple there for the multiples of 48. So the least common multiple of these two values is 96. Now, just be careful, because if we did continue, we would have seen that 192 is also a common multiple. But again, that's why we need to check the values that we had found before, just in case we did continue this. And then we would have found, again, 96 is the lowest common multiple, although 192 is a common multiple. But there's another method that we can use other than the listing method, okay? So that was method one, using just listing those multiples. And generally speaking, most students prefer to find lowest common multiples that way, or even, well, common multiples can occur that way. The second method is a little bit less desirable, at least a little less popular or commonly used among students, and that is to use or to find prime factors. Now, when we say prime factors, that should generally bring up in your mind the fact that we are going to be using factor trees. All right, now that second part that I just put on the slide right there, then multiply with the non-common factors, that's generally where we lose a lot of students, right? It's like, okay, can I find common prime factors? Yes, we can, and we can even multiply those out because it's the greatest common factor. But then we run into the non-common factors, and we saw some of those on the examples, right? There were the numbers that weren't paired or circled with other values. We need to include those in the multiplication. And whatever that is, it will give us the lowest common multiple, okay? But again, you have to start with finding those prime factors. So if you hate this method, or if I get halfway through the problem and you're like, man, I really hate this method, well, hopefully you prefer the first method, right? When we just list the numbers. And again, that's even my preferred strategy or method to use when finding the lowest common multiple. But prime factors is still a valid method. So I'm going to show it. If you hate finding common prime factors in order to find the lowest common multiple, just kind of ignore what I'm doing and do it with the list, and just make sure that your answer is the same, okay? So that would be perfectly fine if you did that. Again, it's not required to use one or the other. We do want you to use one of them because, of course, you're going to have to do problems like this on the assignment. All right, so let's find the lowest common multiple of 4 and 7. But we're going to be using the factor trees on these, all right? So I'm going to start with 4. I'll do that in red. 4 splits up into 2 and 2. Those are both prime. So again, I'm kind of doing this like I would with the greatest common factor. All right, so I got 2 and 2 right there from the 4. And I'll do the 7 in purple right there. Well, actually 7, it can't be split up. It by itself is prime. So I just circled the 7, which means the prime factorization of 7 is, well, 7. Now this one doesn't really lend itself too well to this particular strategy. It's okay, because it still works. So we would say, look, are there any common factors? Nope, there are none. All right. Well, since there are no common factors, we would want to multiply all of the non-common factors. And if there were common factors, we would want to include that in the multiplication. So what are the non-common factors? There's a 2 in red, and then a 7 in purple. Okay. Well, what do we get from the multiplication right here? 2 times 2, that's 4, and then times by the 7. 4 times 7 is 28. So, as it turns out, our lowest common multiple in this case is 28. But just understand, it's slightly rare for this to happen where there's no common multiple, at least prime factors, no common prime factors, like we saw in green here. But in any case, even if you did, like you'd still multiply the 2, and the 7. But if there were any common factors, you'd have to include that in the multiplication. You have to keep that in mind and remember that. So possibly, I mean, just possibly, we should be able to see something like that in this particular problem. Let's go ahead and do 28 in red here. So 28, again, I need prime factorization, so I use the factor tree. So 28, again, you could say it's divisible by 2. I'm going to go with something different because it is one of our multiplication facts that we should know. That's 4 and 7 right there, and 7 is prime. So I'll split up the 4 into 2 and 2, like this, and 2 and 2 are prime as well. So 28, what do we get from this? Factors 2, 2, and 7. I'll do 36 in purple here. Let's go and split up 36. Well, I'll do 4 and 9. I mean, you could do 2 and 18, but I don't know. 4 and 9 seems to work. Or 3 and 12 even. 4 is not prime, so neither is 9 actually. But I can split it up into other prime factors, such as 2 and 2 for 4, and 3 and 3 for 9. Okay, so 36 splits up into factors of 2, 2, 3, and 3. Now again, I'm going to emphasize this again. If you're like, man, I really hate this, even though we've done it before, and you'd prefer to do the listing, do it. Do the listing. That's okay. But I still need my common factors because I'm still using this method. So what are my common factors? I got common factors of 2. In fact, I have another common factor of 2 right there, right? So I got two 2's that are common, but nothing else is common. So I would need to take the common factors of 2 and 2 and multiply it also by 7 and 3 and 3. All right, and this may take just a little bit of extra work. In fact, I may need some extra space on this. So we can start with the 2 green numbers, and I'm going to do this stacked multiplication wise. Of course, if you could use a calculator, this would be easy, but you can't. So 2 times 2 is 4. That's nice. Now I need to multiply by the red 7 right there. 4 times 7 is 28. Okay, we're on a roll. Let's multiply 28 by the first purple 3. 3 times 8 is 24. Carry the 2. 3 times 2 is 6, but plus that 2 is 84. I still need to multiply by the second 3. 4 times 3 is 12. Carry the 1. 3 times 8 is 24. Plus the 1 is 25. So 252 appears to be our final, well, lowest common multiple. Okay, but again, I'm going to emphasize this once again. Not only did we multiply by the common factors, but we also multiplied by the non-common factors. And yes, you could say, well, could we also find the greatest common factor? Yeah, I mean, we did the work for it. The greatest common factor in this case would have just been 4. Not that we need that. Yeah, for a second, I thought I missed something there, but it looks good. So I want the lowest common multiple of 54 and 63. So I'm going to be using the factor tree method. So let's go ahead and split up 54 then. All right. Now 54, I know. I mean, it's divisible by 3, but I don't have my 3 multiplication tables up to 54. So I'm actually going to be using 6 and 9 on that one. I know it's a multiple of 9 and 6. Well, 6 and 9, of course. So I can split these up. 6 will split up into 2 and 3, both of which are prime. 9 splits up into 3 and 3, both of which are prime. So I just found the prime factorization of 54. 2 times 3 times 3 times 3. So that takes care of 54. But what about 63? Okay, well, 63, I know it's divisible by 3, but I don't know my multiplication tables up that high. So I'm going to use 7 and 9. 7 is prime, by the way, and 9, we've already split that up before with 3 and 3. So 63 then becomes 7 times 3 times 3. Now I still want, just like we've seen, the common factors, which is one set of 3's and 2 sets of 3. So 3 times 3, right? So I'm going to take those common factors, 3 and 3, and I need to multiply those by the non-common factors, like the 2, the 3 in red, and 7 in purple. So multiply that by 2, multiply that by 3, multiply that by 7. And so I'm just going to stack this multiplication up, right? I'd start with the 3 and the 3 in green, which is 3 times 3 is 9. Then multiply by the 2 in red. 9 times 2 is 18. That's okay. Now the 3, so 18 times 3, a little bit, it gets a little bit bigger as we go. 3 times 8 is 24. Carry the 2. 3 times 1 is 3, plus the 2 is 5. 54. And then finally the 7. We've got to multiply that by 7. 4 times 7 is 28. Carry the 2. 7 times 5 is 35, but plus the 2 is 37. So this is our lowest common multiple right there of 378